Hello friends, welcome to my channel Printf Developer World. Today our topic is references in C++. A reference is an alias to an already existing object, which means you are going to give a different name for an existing variable. Once you create an alias, you cannot make it point to some other object or you cannot reset it. References are generally safe and make your code look clean. It would also be good if we understand what a pointer is to understand references better. We'll do a different video on pointers, but for now just think that pointer is something that holds an address of another object. Let's try and write some code to understand the references. Here let's create a simple variable integer a whose value is 10, and let's create a pointer to that a. As we already discussed, pointer holds memory of another object. Now p's value is address of a. P is, in simple words, p is pointing to a. Now let's try and print value of p as well as address of a. By our definition, both should print same values. Yep, if we see here, this is the address in hexadecimal 61FE14, both are same. Yeah, now we have some understanding of our pointers. Now let's try and understand if we can change the value of a using our pointer. I want to change the value of a to 20 instead of 10. This is how you do it using pointers. Star p is equal to 10. It will print 20. Yep. Now let us see how we can do the same thing using references. Let's try and create reference to a. Yeah, this is the syntax of creating references. Data type followed by parenthesis and then name of the reference and a. Now aref and a both are same actually. It's just that aref is different name to a. That's what a reference is. Let's see how we can modify the value of a using reference. Sorry, it should be a. Let's run this. It should print 30. Yeah. Now our value is modified to 20 using p, and we have modified the same a using reference. That's how simple it is, Look at line 14 as well as line 21. Line 21 look more cleaner than 14. Now that's the main advantages of using reference. Your code looks cleaner and it's more safe. Now let's try and demonstrate. When we already said that you cannot point point a reference to a different variable unlike pointers. Let's try and demonstrate that as well. I will take the same example. Int a is equal to 10 and int star p is equal to address of a. Now let's take another variable int b is equal to 20. And let's point our p to b. Yeah. Now if we try to change star p, right, our b gets modified but not a. Let's see that. See, our A is still 10, but B got modified because our P is no more pointing to A, it's pointing to B here. We have modified our P to point to B at line number 11. That's why we could see that value of B is modified. We can't do this with references. Means once we create reference, it will always stick to that particular variable. We cannot do that. That's why pointers are more powerful than references. Let's demonstrate that. Now ref A is equal to A. Now ref A is equal to B. And again let's try and print the value of A. It will print, what do you think it will print? It will print 30. Yep, because value of B is 30. We have modified it at line number 13. So value of B gets assigned to A. So your A got modified. Unlike pointers, since unlike pointers we saw that P was pointing to A earlier and then we changed it to B. But references are not like that. They were completely different. Any changes to ref right will always get reflected in A, because your ref A is always A. It cannot point to something else. I shouldn't say it point to, but your ref A is just A. Anything gets reflected A will always change to the original the variable that we assigned it during the creation of a reference. That's what we mean. Pointers cannot, references cannot be reseated, unlike pointers. That's why references are safe and less error prone, because you cannot go and mess with someone else's memory. Now let us try and understand one more use case of a reference. Let me create a simple class sample. I'll write a constructor. Whenever our objects get created, this constructor gets invoked. Sample object created. We have one more special type of constructor that gets invoked when a new object gets created out of old object. That is nothing but copy constructor. We are going to write our copy constructor as well. This is our copy constructor. This is our constructor. This is our copy constructor. We'll discuss more about copy constructor, but for our understanding, let us understand that this is a special type of constructor that gets created, that gets invoked when an object is created, when a new object is created out of old object. Yeah. So even this copy constructor gets invoked when an object is created. Let me also add a member variable A. Yeah, we have written a simple class sample with a member variable A of type integer and a constructor and a copy constructor. Now let's create an object A and assign value of 20 to variable A. Now our output should print this, because we have created, yeah, if you see, sample object got created, was printed. Now let's try and write one more function, change sample object what this function does is it simply modifies value of a to 10. Oops, it should be obj because there is no s here. Yeah, what we did is we created an object of type sample and we assigned value of 20 to a, and we are trying to modify a using inside this function change sample object, which takes parameter of type sample. So ideally we should get value of a should be 10 because we have modified its value inside this function. Let's see what gets printed. Oops, we got 20 printed. The reason is when we passed this object inside this function, right, it's it's passed by value, which means a new temporary object gets created out of this object. That is why if we see this, right, we got two print statements, sample object got created, which means a new temporary object got created and we modified that value. We modified that object's a instead of this object. To make it clear, right, sample copy constructor, yeah, now let's, yeah, our copy constructor got invoked when a sample object got created. Yeah, this is the disadvantages of passing by value, because if you want to modify this object, right, you have to always pass it by reference and not pass by value if you want your changes to get reflected for this particular object. To do that, you just change this method to take the references of s instead of a value of s. Now let's try and check. See, our object's value got modified. That means we modified a as 10. Now that's how your references are useful. And assume if your object is heavy, right, in that case you're creating a new temporary object which is costly. In this case we have a simple class, so it doesn't make any difference. Assume if we have some huge member variables, huge data inside this sample, then a new object gets created. That is the disadvantages of passing another disadvantages of passing by value. One disadvantage is you don't go and modify the actual object, rather you modify the temporary object that's created. That is one disadvantage if you pass by value. And the other disadvantage is if your object is too heavy, that means it has more number of variables, huge memory is allocated, you are using dynamic memory. Now your heap memory gets increased because of the sample objects getting created. Assume if you create 100, if you call this function 100 times, then 100 objects of type sample gets created, which I think is unnecessary. That's how your references are helpful in C++. Hope you understood the usage of references in C++. If you like my video, please like, share and subscribe. Thank you.